Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, no problems today. Today we're going to talk about ocean productivity. So this is our living things that we talked about last time. How do they produce, right? Not like reproduce, but production. So let's talk about this. What's this a term here? Something called primary productivity. This is it is the amount of carbon available for creatures to survive. This is usually caused by photosynthesis. And as we talked about this, in the ocean, the primary the primary creatures that do these are the phytoplankton. Because they are the primary, most of the bottom, if you will, food chain, which we'll talk about next, starts with these creatures right here, and everybody eats them, who eats them, who eats them, who eats them, that kind of a thing. So let's think about this primary productivity and what do you need to make this happen? So what are the two factors that you need to make the phytoplankton do well? Turns out you need, well, two factors. What are the two factors? Number one, you need the sun. Without the sunlight, game over. You need lots of sun, right? Sun matters. And the other thing that you need is nutrients. You know, in the ecosystems of land, if you've got a desert, lots of sun, but the soil isn't very good. All right? But in the ocean, you need good, there's no soil, so to speak, because that's at the bottom, and we need it to sort of float up. So the nutrients are found at the bottom of the ocean. All right? So to make productivity, to make lots of phytoplankton, which makes the basis for the entire aquatic organisms to survive, you've got to have a combination of sunlight and nutrients. So you might ask the question, where do you find the richest soil, the best waters for living things to happen? Well, let's talk about the different regions of the earth and look at them and ask the question, do they have enough sunlight? When do they have enough sunlight? Are they getting their nutrients? So let's first talk about the tropical oceans. Now clearly they have a lot of sun, but because of the thermocline, recall that, there's not a lot of mixing, so there's not a lot of ways for the nutrients from the bottom to get to the top. So interestingly enough, the tropical oceans are the deserts. There's not a lot of life because there's no food. There's no phytoplankton. The thermocline is so strong that it doesn't allow mixing to happen. All right, let's change gears. Let's look at the polar oceans. Now clearly the polar oceans are often covered in ice, but when they're not covered in ice, there is a time of year, you know this probably, at certain times of the year it's dark, no sun. But in other times of the year you've got sunlight extraordinaire. So sun in the summer, now say summer, it could be our winter if it's down in the southern hemisphere, right? So they get interesting things happen like this. So here's a graph of the plankton in the polar regions. Notice how it peaks in the summer. Makes sense, doesn't it, right? And there is no thermocline, all right, that's important, right? There's no thermocline in the cold polar oceans, but because of that, then there is no barrier for the nutrients to rise up and be eaten or used up by the phytoplankton. So this is why the polar oceans, they have something happen. Now the most interesting part of the world is what we call the temperate ocean. Now the temperate oceans aren't, you know, right by the equator, they're in between the equator and the polar regions. And if you look at the picture of the temperate oceans, it's complex. Look at that. You've got a phytoplankton with the peak, got the zooplankton coming down, and you can see the different times of sunshine, and there's different sparks or spikes, I guess is the word I'm looking for, because it turns out in the temperate oceans that you get two interesting things happening. In the winter, well, let me just say this, you basically have a spring bloom, and then you have a fall bloom. That's where you see the peaks right there. And what starts to happen is because as the oceans are going over and the temperature is starting to warm up of the oceans, then you get the turnover. If you can get the stuff from the bottom up, then there is something for them to eat. And this is crazy where this happens. A place that you might not think about, you might think it's polar, but off the coast of Alaska, it's temperate oceans. And the fishing there is amazing. Why is it amazing? Because especially in the spring, there's the spring bloom, all the phytoplankton eat, then the zooplankton, and then whales come to eat, and then seals and otters and fish and fish and fish. So the temperate ocean has these two big peaks that are called the spring and the fall bloom. But when you move back to, say, the summer, then you get a strong thermocline, because you see, what you need is these changes in temperature to keep changing, and changing temperatures causes circulation of the ocean, which causes the goop from the bottom. That's what you want, the goop, to get up to the phytoplankton so they can eat, survive, grow, be eaten, be eaten, be eaten, be eaten, and eventually a whale gets it. So Houston, productivity, it's an interesting thing. In our last video in this particular level, we're going to talk about how they eat, right? We've talked about this is where the energy comes from, and that's going to go there next. But actually I forgot one thing. Hold on, back up. I forgot to talk about one more topic, and that's called biomass. Now biomass, mass of bio. This is the mass of all living things. Actually, their mass, their weight, right? If you weigh them, now we often talk about the biomass of the earth, right? And when we think about the biomass, I have biomass, right? My muscles here, my brain, my eyes, I have mass, you have mass, trees have mass. And often we talk about the earth biomass, but sometimes we talk about the marine biomass. So marine has to do with, of course, the oceans, right? So it turns out that the oceans are about 3% of all the biomass of the earth. Only 3. Is that crazy? It's 97% of the weight of the earth, of the weight of the living things. That's what that is. The weight of all the living things is on land. Only 3% is in the water. And one of the big reasons is that we don't have. Let me think about how to say this. The plankton live and die quickly. But a tree, which is a primary producer in the real world, in the terrestrial land, he lives for hundreds of years potentially. And so his mass keeps going. But a phytoplankton is born, he lives, he dies, and this happens very, very quickly. So there's not a whole lot of like steady creatures that last for a long, long time in the ocean. Now some of the whales and things like that will live for a long time, but their primary source keeps being recirculated every year. And if you break that circulation, we're going to have a crisis of great proportions in our ocean. So the biomass matters. Anyways, funny, mass matters. Guys, next up, like I said, we're going to go back and we're going to talk about, lastly, about who eats who and how that works. We'll see you in class.